What specific problem does the Source2Synth method aim to solve in the context of large language models?
The Source2Synth method aims to address the limitations of large language models, LLMs, in performing complex tasks that require multi-step reasoning, tool use, and the manipulation of structured data. Specifically, it seeks to generate high-quality synthetic datasets grounded in real-world sources without relying on expensive and time-consuming human annotations. By automating the selection of seed topics and leveraging external data, Source2Synth enhances the realism, diversity, and factual accuracy of the generated examples. This method is particularly applied to challenging tasks such as multi-hop question answering and tabular question answering using SQL, ultimately improving the performance of LLMs on these tasks. The approach consists of 3 stages: dataset generation, curation, and model fine-tuning, which collectively yield a scalable solution for enhancing LLM capabilities.
How does the Source2Synth algorithm work? Illustrate its methodology step by step, detailing each of the 3 stages: dataset generation, dataset curation, and model fine-tuning.
The Source2Synth algorithm operates through 3 distinct stages: dataset generation, dataset curation, and model fine-tuning. 1. Dataset generation. This stage begins with selecting a real-world data source, such as tables or Wikipedia articles, to ground the synthetic data. A seed topic is then generated from this source, which serves as the basis for creating examples. The algorithm generates a full example that includes an instruction, e.g., a question, a reasoning chain detailing the steps to arrive at the answer, and the answer itself. 2. Dataset curation. In this stage, the synthetic dataset is split into 2 slices. The first slice is used to fine-tune an intermediate model, which is then employed to curate the second slice. This curation involves 2 processes: imputation, where parts of examples are blanked and filled in by the model, and filtering, where examples that fail to produce correct answers after multiple attempts are discarded, ensuring higher quality data. 3. Model fine-tuning. Finally, the curated dataset is used to fine-tune the model. This involves supervised training on both the reasoning chain and the final answer, resulting in a model that is better equipped to handle complex tasks, such as multi-hop question answering and tabular question answering.
Can you provide a simple example illustrating how Source2Synth generates a synthetic example, including a description of the seed topic and the resulting reasoning chain used for answering a question?
Source2Synth generates a synthetic example by first selecting a seed topic from a real-world data source, such as a Wikipedia article. For instance, if the seed topic is the entity Apollo 11 inches from an article about the Moon, the method would then generate 2 related questions. One might be, what was the spaceflight that first landed humans on the Moon? And the other could be, who was the commander of Apollo 11? The reasoning chain involves linking these questions through the seed entity, allowing the model to merge them into a multi-hop question, such as, what is the height of the student that topped the entry exam? This process not only creates a coherent question, but also provides a structured approach to arrive at the answer by breaking down the reasoning into smaller, manageable steps. Thus, the seed topic serves as a conceptual link that guides the generation of the entire example.
What are the specific advantages of using Source2Synth over existing methods for generating synthetic datasets, particularly in terms of quality and efficiency?
Source2Synth offers several specific advantages over existing methods for generating synthetic datasets, particularly in quality and efficiency. Firstly, it does not rely on human annotations, which significantly reduces the time and cost associated with data generation. Instead, it leverages the LLM itself to enhance the quality of the synthetic data. Secondly, the method automates the selection of seed topics from real-world data sources, ensuring that the generated examples are grounded in realistic and diverse information. Additionally, Source2Synth employs a robust curation process that includes filtering and imputation, which systematically improves the quality of the dataset by removing low-quality entries and refining the generated examples. This results in a curated dataset that leads to better performance in fine-tuning LLMs for complex tasks, as demonstrated in both multi-hop and tabular question answering scenarios. Overall, Source2Synth provides a scalable and efficient approach to synthetic data generation that enhances the realism and effectiveness of the training data.
How was the effectiveness of Source2Synth validated during the experimental process? Describe the datasets, benchmarks, and metrics utilized to demonstrate its performance gains.
The effectiveness of Source2Synth was validated through experiments on two primary tasks: multi-hop question answering (MHQA) and tabular question answering (TQA). For MHQA, the method was evaluated using the Hotpot QA benchmark, which consists of 113,000 examples of multi-hop question-answer pairs, focusing on bridge questions that require reasoning over multiple documents. The performance was measured using the Soft Exact Match (SoftM) metric, which assesses whether the generated output contains the correct answer. In the TQA domain, the Wiki SQL dataset was utilized, comprising 80,654 hand-annotated examples, with performance evaluated using both Exact Match M and SoftM metrics. The results showed that the curated synthetic dataset from Source2Synth significantly outperformed various baselines, including instruction-tuned models and models trained solely on uncurated synthetic data, demonstrating substantial performance gains in both tasks.
What notable results were attained through the application of Source2Synth across the two domains it was tested on, and how do they compare with baseline methods?
The application of Source2Synth yielded significant improvements in both multi-hop question answering (MHQA) and tabular question answering (TQA). In MHQA, the model fine-tuned with curated synthetic data, LLM curated, achieved a performance gain of 17.44% over the base model and a 14.56% gain compared to the LLM fine-tuned solely on Hotpot QA data. For TQA, the Source2Synth method resulted in an exact match M score of 34.5%, which was a substantial increase from the 23.86% M score of the LLM synth model that used uncurated synthetic data. In contrast, the instruction-tuned model without any context had an EM of only 0.25%, highlighting the effectiveness of the Source2Synth approach. Overall, Source2Synth consistently outperformed baseline methods, demonstrating its capability to enhance LLM performance on complex tasks without relying on human annotations.